It's my pleasure to next introduce Deann Taylor, who was a colleague back when I was at CHOP. Deann is the Director of Bioinformatics in the Department of Biomedical and Health Informatics at CHOP. Her expertise is in translational computational biology and in computational systems biology. And she'll be presenting on developing a pediatric open targets platform utilizing CBTN data. Slides.
Okay, great. So I'm, for those of you who don't know me, I'm one of those people that works kind of in the DCC for Kids First, a lot of harmonization work, and especially in data elements from clinical data element kind of work. And I'm also coordinating PI on a fairly new, it's not a grant, but it's a contract with NCI for Open Targets Pediatrics. Hasn't been announced yet as part of a bigger strategy, but this is something that's fairly new. We've only just been really starting to work on this since March. So next one. So you all know the Race for Children Act clearly. I've heard it repeated many times and over the day. Essentially, this project is really in response to the Race for Children Act, specifically for trying to enable people to use the relevant molecular target list on the FDA's pediatric relevant molecular target list that, you know, shows what kind of targets should be used in pediatric cancer research. And also to kind of empower the people who are offering new data, targeting or presenting new possible targets, and also helping pharmaceutical companies kind of look over the landscape of pediatric cancer. So for those of you who may have not run across the relevant molecular target lists, there's two of them really. One is the relevant molecular targets and one are non-relevant molecular targets, which is really much smaller. But the relevant molecular target list is several hundreds of genes, and they are considered to be at one point expertly created by people who understood the cancer landscape on multiple tumors, hit the literature, came up with a list of genes. And this list is being kind of curated by us a little bit, and it will go back to the FDA with some additional addition or kind of clarifications we made to the original. But we're going from this list and trying to see if we can help people prioritize these lists for research in looking at therapeutic treatments. So to support the Race for Children Act and the RMTL, we've decided to extend a platform that already exists that was developed at the Wellcome Sanger called Open Targets. And it's an existing portal system. And at CHOP, we're going to be analyzing and harmonizing data to put into this platform, which I'll show you in a minute. And Leidos and NCI are working with us to actually adapt the web and the back end, the DevOps part of that platform, the more technical side of that, to make it ready and available for people to load data up for pediatric cancer that's specific to the kinds of things that clinicians, pharma, and other users of that resource would like to see. And this extension to Open Targets is actually going to provide target and drug information, genomic evidence, and preclinical testing data, specifically for pediatric cancers like the PPTC, to support the Race for Children Act. So the Open Targets platform was developed, as I mentioned, at the Wellcome Sanger Institute, and they're actually partnered already with pharmaceutical companies. So this is not just an academic platform. This is a platform that has been duplicated and used interior to pharmaceutical companies, and in some very special ways is supported by the pharmaceutical companies on the back end. And also EMBL EBI in Europe. So a lot of this is supported also by the EMBL and EBI. And a lot of the data that comes into Open Targets comes from various types of EBI projects, including Chembl and the Expression Atlas in EBI. So the Open Targets platform actually supports the systemic identification and prioritization of potential therapeutic drug targets. And how does it do this? It brings in all these disparate data sources, creates a score for a target versus a disease. And I'm not going to be able to go too much into detail how they do that today because I only have 20 minutes, but it is freely available. We do have the ability to change that scoring, to make our own changes to the platform. And our first step, we're going to start adding pediatric data to the Open Targets portal from CBTN is one of the sources we're using, and using resources from the Open PBTA project that has a lot of great and reproducible modules and methods or tertiary analysis methods that are going to go, the products of that are going to go into this platform. So for example, we could put a search in for medulloblastoma to the Open Targets platform. And then what you'll get back is, this is just on the search term in the very front page before you hit return, it's going to do an automatic fill in for you, where you'll get like medulloblastoma comes up at first. This is the disease, and they'll show you kind of popular targets or disease and phenotypes and drugs that are already related to that. But if you click into this, you'll see a page like this, and this is the original Open Targets, not our version of the Open Targets, which is probably going to have some substantial differences. But in the original version of Open Targets, in their medulloblastoma categorization, they have roughly about 3,000 targets associated with it. These are genes or gene types or target types. And then they're ranked by an overall association score, but based on evidence from different data modalities. And these data modalities could be actually the drugs that target this gene that are active in medulloblastoma, somatic mutations, genetic associations, which comes from actual genetic studies that have come from the literature, text mining in the literature, RNA expression from more than one or more sources. Somatic mutations can come from cosmic and other databases, and animal model data. But clearly there's also things, we could have PDX models in here. There could be additional data in here from like copy number variation, things like that maybe that could fall into somatic mutations, but you can imagine we could have a lot of other data that comes in here. And part of our job is actually altering this interface to add more data. So, you know, there's different evidence types, as I mentioned. These are all the different evidence types from different sources that are in there right now. There's also this evidence weight heat map. The darker the color, the more evidence or the more of a higher score there is. So that's easy visualization. And also this overall association score is calculated based on the evidence and different weights of the evidence, which we are also able to change specifically for pediatric cancer. For example, if we believe genetic associations are more important in pediatric cancer than in a generic adult disease, we could upweight genetic associations for the overall association score in our methods. And also, there's also several different types of evidence-specific filters that you can select, and we could add them in, and that allows researchers and people using the interface to select for different types of associations, different pathway types, different target classes, and different tractability scores. So we've worked out several use cases. Part of our ask is to create several use cases that could be prioritized and evaluated for success of the platform. And, you know, there's different types of data that could come in for these use cases. And I'll talk a little bit some use cases in a minute, but we could have RNA-seq, somatic mutations, proteomics, preclinical testing, any kind of data could come in for that. And we've also identified pediatric focused data sources. So OpenPBTA and the CBTN data sets that have come through from the CBTTC and PBTA. That kind of data is kind of like our central pivot, actually, for other data processing, because OpenPBTA did such a good job, we believe, in taking data, for example, from the Kids First pipelines and updating it with tertiary analyses and downstream analyses, that we wanted to use that as a central pivot for all the other pediatric cancers we're going to be processing through. So that includes target Kids First cancer data sets and things that might come out of the PPTC or other pediatric data sets. This is not exhaustive, but this is what we have so far. And there are other data set sources as well. This is the GTEx, which we can use for, even though it's adult, it could also be used for kind of control data, the TCGA, and of course the RMTL that I mentioned earlier. And then the data processing pipelines, as I mentioned, we have the Kids First data processing pipelines for all different types of data related to cancer. And we also have the OpenPBTA project modules. And those are the validated processing scripts I mentioned for PBTA data that can be used for processing all our other childhood cancer data. And that's our plan right now. So this is kind of the big picture. For Open Target's pediatric extension plans, we have these data at the top here: Target, PPTC, Kids First cancer data, PBTA data, et cetera. Adult reference data that would come through. And then we have analysis and harmonization pipelines from OpenPBTA, et cetera, that would come through. And it would all be put into an Open Targets database. Now, this is not a distributed database. It is a centralized database that the website operates from. And then it will add harmonized pediatric data, preclinical treatment evidence, and et cetera. They're especially important for us are the compatible ontologies. And I'm not going to go more into that right now, but we're basically NCIT and Mondo are going to help guide and work with Sam, who's going to be talking, I believe, later. Are also people that we're going to work with to make sure the ontologies for the pediatric and for the histologies are going to be correct. And it's going to deliver drug and disease and gene evidence information, data, categorizations, etc. All of these things are going to be in our own particular view for this. And our use cases are, I've left several out of here, but regulatory, should the gene be added to the RMTL list? Should it be something that called attention to developers or people who are doing research? For pharma, what are the evidence that something should be targeted? And innovators, if you're in a new small company, you've got a new drug, for a particular target, is there a pediatric indication for that? And in academics, of course, there's all kinds of uses for this kind of platform, both for understanding a target you're working on and maybe what other people have done on it. And so an example use case would be, for example, a company is bringing a TIGIT antibody, targeting antibody to phase 1 clinical trials. Is there a pediatric indication? So in this case, you could search for the TIGIT gene, TIGIT here, the T cell immunoreceptor gene, and you could call this up and you could actually you could sort by text mining, sort by, you could select out cell proliferation. Right now, we don't have a pediatric cancer checkbox, but we're going to build that in. And for now, I'm just looking at cell proliferative disorders. So that's basically neoplasms. And if you look at this, the biggest hit right here would be text mining. You could go in and read about the text. It'll have links to the bibliography, and you could look at, some of the existing effort. There's not a lot here. The idea is that there should be a lot more once we get pediatric cancer in. And another thing is we would like to have visualizations in this particular resource, but right now they don't have the visualizations like you get from PC Bioportal. So temporarily, we're going to have a link to PC Bioportal here for this gene, and you would be able to hopefully link directly into PC Bioportal if you have your account, and actually start looking at the data in this resource until we're able to build similar plots in open targets. So for a short-term stopgap, we're going to definitely be using PC Bioportal because it's very useful. Another one is, this is just a quick one. This is another example of using the RMTL list, trying to update the RMTL list. You would say, could we propose this gene? It's proposed to the FDA as a new relevant molecular target since it's overexpressed in Ewing sarcoma. So you could actually also do a search on this and different types of data. Again, we're missing pediatric cancers from this, but this is something we can add in. And again, we can link to PC Bioportal and start looking, for example, all the sarcomas and seeing what kind of changes are made to the gene in its expression analysis. So overall, the pediatric data processing ingestion open targets, essentially we're going to start with use cases and RMTL lists, and the portal views. And these are all things that are going to be coming from the users. What do the users want to see? Do they want to see, what kind of portal views are important to them? What kind of use cases are important to them? And we've gotten some feedback from some clinicians on that, and we're definitely going to be looking for more information on that. The data will be accessed and ingest based on what's needed in the use cases. We're going to take primary analysis, for example, and actually run it through Kids First pipelines and harmonize those data against standards. Then once the data is harmonized and it's run through the pipelines, we can use the open PBTA modules to do tertiary or more ordered types of analyses like for fusions or differential gene expression that could go and displayed in the portal. And then once that data is conditioned properly and we're ready to upload it, it can be uploaded directly into the open PBTA database, and then there'll be portal views available to the user. And that's pretty much the pipeline of how we're doing it, and we're currently working on this right now. There's other opportunities that we haven't talked too much about in our group, but this is always here for the community, and we would love to have feedback. There's other things that we could do. For example, we could have a medulloblastoma forum on here, and that could link researcher communities, and especially for target development or pharma research communities, clinical data resources, data processing resources. We could link in a lot of different things into these pages that would be very specific for target identification, but also be useful to the community. So that's other things that we've kind of talked about maybe doing. And also, of course, regulatory resource links if anyone would like to have more information on the RACE Act. And one thing I did not mention in this is that all of these genes that we had saw previously in some of our use cases will have a link or a divot next to them, some kind of star next to them, or some sort of annotation that those genes are part of the RMTL. So when you get your list of genes that are prioritized, there'll be a link next to them that says this is part of the RMTL list, just so you know, and you'll be able to faceted search just on the RMTL. So this is the team that's actively working on this right now. We have our pediatric oncology team, people we consider to be experts in pediatric oncology that are local to CHOP. And John Maris is my kind of co-PI on this grant, although he's kind of overwhelmed with his other stuff. So he's definitely the pediatric oncology lead on this. And of course, Adam, Sharon, and Sarah are all indispensable for this work. And the data harmonization team, you'll probably recognize a lot of these names from their work already in the PBTA work, but like Jo Lynn and Kavatika and Kamal, Allison, and other people on this list. So Yunkun. And so if you have any information that you'd like to share with us or any suggestions, there's my email at the bottom. And please contact us. We'd love to hear from people who are interested in this resource. It is not up yet. We're hoping that we can stand something up by the end of August. Thank you very much.
So Deanne, that was a wonderful presentation. When it is up and available, if you let us know, we can also disseminate and make sure that our community is aware. But this is a wonderful resource. I don't see any questions on the chat, but I will pause for a sec to see if Adam has a question or a comment or.
Yeah, two questions. One is, Deanne, maybe you can comment. There's a question by Ricky Martin about potential connectivity to adult data. And this is something that changed recently that maybe you can comment about.
Comment about the connection of this data to adult data?
Yeah, the idea of TCGA and GTEx and other data sets that, your team has begun to address.
Yeah, there's three different ways. First of all, we're adding things into open targets, but we're not removing anything. So there'll be adult data, at least in the fact that there are adult diseases in there, even though mixed in. But also a lot of some of the comparisons we'll be doing on the pediatric, especially the RNA-seq data, we'll be using GTEx as a reference. And we're talking to people who, including Adam and other people, about what the best way to do would be to leverage the GTEx and the TCGA data as comparators to the pediatric data. So we've got some plans for that, essentially using GTEx as a control or TCGA histologies as a control correctly, according to what the oncologists tell us is the most reasonable way to compare them.
Yeah, perfect. And then there was another question, which I think is really great. We often talk about different platforms with different names. And the question asks, what's the difference between Kavatika and open targets? And I answered, but feel free to comment at the end that, open targets is really an aggregator of process data and annotations. And that indeed, most of the data that we're currently bringing into open targets is being processed on Kavatika. So Kavatika is the compute and analytic environment that feeds portals like open targets.
Correct. And we're hoping that the data that has gone through Kavatika that populates open targets should also by itself be available as bulk, hopefully through the cancer data warehouse. So you'll have the access not only to the process data in open targets, but you'll be able to download what we've been able to process yourself and use it if you'd like. So so Kavatika is kind of like the engine, while open targets is like the portal that will display it. Yeah.
Perfect. Thanks.